everybody! Today we'll be solving question number 5 on the non-calculator part of the 2010 AP Calculus AB exam.
Aujourd'hui, nous sommes étudier une question de la calcul dans le AP examen nous passons en 5 de mai.
Diana, this is Mr. French's class, not French class.
Oh, right. Well, now you see this intricate graph of g prime of x, and you might be slightly confounded here.
The function g is defined and differentiable on the closed interval -7 to 5 and satisfies g of 0 equals 5. The graph of y equals g prime of x, the derivative of g, consists of a semicircle and 3 line segments, as shown in the figure here.
To solve this problem, you need to know the basic properties of integrals, their definitions both as the area under the curve and the antiderivative. You also need to know how to use derivatives to find critical points and points of inflection, and what these all mean.
Remember, the first derivative tells you the slope of the tangent line to the curve, whether the function is increasing or decreasing. Whether the derivative changes from positive to negative, the function changes from increasing to decreasing and has a maximum. When the derivative changes from negative to positive, the function changes from decreasing to increasing and has a minimum.
Points of inflection, or changes in concavity, on the graph of the function occur when the second derivative, or the derivative of the derivative, changes sign.
Note that g of 0 equals 5, and most importantly, remember this is a graph of g prime of x, not g of x.
Find g of 3. In order to find g of x, we have to take the integral of g prime of x from 0 to x. The integral is the area under the curve and above the x-axis. For g of 3, we have to remember that for g prime of x, from g prime of 0 to g prime of 2, it is a quarter circle with a radius of 2, while from g prime of 2 to g prime of 3, it is a line segment. G of 3 is the integral of g prime of x from 0 to 3, which is g of 3 minus g of 0. We find g of 3 by finding the area under the curve. For the quarter circle, we know the area is 1/4 pi r squared. And by plugging in 2 as a radius, we get that the area of the quarter circle is pi. We treat the area under the line segments as a triangle with an area of 1/2 base times height, where base is 1 and height is 3, so the area is 3/2. We add 5 to pi plus 3/2 because 5 is a starting value, g of 0, of the function. So the final answer is pi plus 13/2 for g of 3. To find g of -2, the integral of g prime of x from -2 to 0 is equal to g of 0 minus g of -2. And we take notes that this segment from -2 to 0 is represented by a quarter circle. We find the area under the curve from g of -2 to g of 0 is pi because 1/4 pi r squared with radius 2 gives us an area of pi. So we plug 5 in for g of 0 and set the expression 5 minus g of -2 equal to pi. Then solve for g of -2, which turns out to be 5 minus pi.
Find the x-coordinate of each point of inflection of the graph of y equals g of x on the interval from -7 to 5, and explain your reasoning. Points of inflection occur when the concavity changes, so they will occur on the graph of y equals g of x when g double prime of x changes sign. This will happen when g prime of x has a slope that goes from positive to negative or negative to positive, like right here, and here, and here. So all we do is look at the graph of g prime of x, which we are given, and find the x-coordinates of the points where it changes from increasing to decreasing, like 0 and 3, or decreasing to increasing, like at x equals 2. And so we have that the graph of g of x has inflection points at x equals 0, 2, and 3.